Okay, so this is question 15. It's quite a tough one, and you have a probability distribution in a table here. And when you look at the actual values of the probability, they're given in letters Q's and P's. But we do know an important bit, right? We know that the sum of all these probabilities are 1. So basically, Q here has got to be all of these others subtracted from 1. All right, so Q equals 1 minus all of these other probabilities added together. So look, I've written it down here. Q equals 1 minus all these probabilities added together. Now you can expand that and tidy it up, but no real need to, but we can find it, because if I take this a little bit further, I can just say, well, look, Q here, if you look at this, this is inside the brackets, you've got 4p squared here, but then you're subtracting 4p squared. Right, so that just cancels each other out. And then in brackets, you've got p plus 0.7. So you've got q equals 1, and then we'll expand the brackets, minus p, and then that'll be minus 0.7. So therefore, we've got q equals to 1 minus 0.7 is 0.3 minus p. So that would be the nice tied up answer, but there is q in terms of p. Now, we don't really need this actually for the final, the part B and part C, because it wants you to know the value of P, which gives the largest value of E of X. Well, look, we know how to calculate E of X. It's just all the sums of 0 times Q plus 1 times 4P squared plus 2 times P. So let's go and write that out. Let's go and write what E of X is and then discuss it from there. But look, 0 times Q is going to be 0 anyway, so that'll cancel each other out. So we have down here, we have E of X, well, let me just change that, E of X, and that equals to 1 times by, okay, let's just go back to the table. All right, look, 1 times 4p squared plus 2 times p. In fact, I'm going to copy this down. Look, I'll do a little shortcut, because these are the numbers, right? So it's 1 times 4p squared plus 2 times p, right, 2 times p, plus 3 times 0.7 minus 4p squared. There you go, that's E of X, right? That's an expression for E of X. So we've got one variable, this guy here, depending on one other variable, the p. So actually we can plot a graph of this. I mean, it doesn't sound the most logical thing to do, but basically for different values of p, imagine p was 0.1 or 0.2 or 0.5, each value of p we try in here will give a different E of X. Yeah? For very small values of p or very large values of p, that might have obviously a different effect on E of X. But look, we can actually draw this as a graph. We can take all of this, we can copy it down, and on the y-axis, let me just paste it, we can, on the y-axis, which represents E of X, and on the x-axis can represent the p. All right, so this is what we're plotting. I'm going to take away the x, which this times multiplication, and just put the little x there, right? There we go. And this can go away, and this is an x. So anytime you see a little cross, it's a variable x. So this is the graph we want to plot. Now when I take this and put it into a graph doc, insert a graph, it won't paste very well, but we can do it. So what was it? It was 1 times 4x squared. So that's just 4x squared, right? Plus 2 times p. Yeah, so that was 2x and then 3 times. Okay, so that is 4x squared plus 2x plus 3. Yeah, that looks good. And let's go graph that. Fantastic. And then we want to find, if I do a little change of the scale here, I'll change that to 1. And I'll change this to negative 0.1. And can you see that these are the values of p? Now, p obviously has to go between 0 and 1. It looks like p can't be more than about 0.6 or 7. Then we have negative values down here. And here's E of X. Look, the y-axis represents the E of X, the mean, the expected mean. So we do menu, analyze graph, we look for the maximum, point before, point after, and we've got it, look. The p value that gives the maximum is 0.125, and that gives us an E of X of 2.22. So we would just copy this down and paste it in here. What we do is we draw a graph of that to show that we know what we're doing, basically, right? So if I just take a screenshot of this, this is what you would do on an explanation. You'd write this up, you'd say that you are plotting this as a graph, and then you would do a sketch of the graph. I'm going to insert a picture, hopefully, right? And then from there you would say P equals 0.125, and that would give you an E of X of 2.22. Okay, so those are the values for P that will lead to a maximum value of E of X. And you need to write the P and the E of X, don't leave it in terms of X and Y, right? Because on the Y-axis, that represents E of X, and the X-axis represents the values of P. I hope that helps. That's a nice tough one. That's probably, yeah, I would say that's getting on for a level 7 question.